Algebra 2, lesson 66, signs of fractions and 30, 60, 90 triangles. Or that should just say triangle. Oh, that's all right. 30, 60, 90 triangles. Signs of fractions. So some of you may have noticed there are 3 locations where you can put a negative sign in a fraction. I'll go ahead and draw this. So if we have the fraction 3 over 4, like the one that they're demonstrating, we can either put a negative sign or a positive sign here, a negative or a positive here, and a negative or a positive here. Now, if I was going to write this fraction as a negative, there's 3 ways I could do it. I could either write negative 3 over 4, I could write 3 over negative 4, or I could just write, I'll go over here, negative 3 over 4. All 3 of these are the exact same number. Here's why. If I were to take 3 divided by 4, that's a negative divided by a positive. That gives me a negative. I'm back at negative 3/4. If I take positive 3 divided by negative 4, positive divided by negative, answer is going to be negative, so it becomes negative 3/4. Now, the opposite is true too. I can take this negative and I can apply it to the numerator, or I can apply it to the denominator. So, interesting thing in fractions is that the negative is kind of, it's inconsequential. It doesn't matter where we put it in any of these 3 places. We're not going to change the number. And that's because fractions are essentially a ratio. And if it doesn't matter where you apply a negative to a ratio, it'll still be the same ratio. Now, what if there's more than one negative? Well, if I have a negative 3 over 4, those 2 negatives are just going to cancel, so the number is going to be positive. And if I move it to the bottom, I have negative 3 over negative 4. Again, they're going to cancel. It's going to be a positive again anyway. And then what if both the negatives are in the fraction and not outside of it? Well, those are going to cancel. The answer is going to be positive anyway. So it doesn't matter where the negative is. It can be applied to either the numerator or the denominator. The reason why they're bringing this up is because we're going to start adding complex fractions that are negative. And some of you will ask, where do I put the negative? Do I distribute it to the top? Do I distribute it to the bottom? And the answer is it doesn't matter as long as you put it in one of these 3 places. So let's go ahead and go to an example problem. I'm going to make it magically appear. Watch. Ta-da! Instead of doing 3 or 4 examples of this, I'm just going to show you one, and then we'll go from there. Let's see here. So we have this problem, and we have to add these 2 fractions. Now we see that the denominators are not the same, right? Well, they can be. It depends on how we deal with this negative. If we apply this negative to the numerator, the denominators are not the same. Negative x plus 3, it looks different, right? However, if we apply this negative to the denominator, we then have to incorporate distributive property. So this negative will go to the negative x and go to the positive 3. So what that becomes is 1 over x minus 3, and that negative sign now turns into a positive because we're adding a negative number instead of subtracting. And then the denominator, negative times negative x gives me positive x, negative times positive 3 gives me minus 3. So I now have the same denominator, and I can write my answer as just 1 plus 7a over x minus 3. That was easier than I thought it was going to be. Maybe I will do 2 examples. Let me see here. Let's see. Let's do this next one. I'm going to make this one magically appear too. Watch. Ta-da. Okay. Again, same thing. We have 2 fractions. The denominators are not the same because 3 minus x is a little bit different than x minus 3. Now, using that rule of negatives in the denominator, I can rewrite this as 2x minus 3 over negative x plus 3, right? And then from there, I can factor out a negative here, or I can kind of move the sign of a negative. So I rewrote this like that. And I'm essentially just going to multiply by negative 1, positive 1. But again, if I write a fraction, I put negative 1 over negative 1, that's the same as positive 1 because the negatives would cancel and the 1s would just be 1. So this little trick will help me rewrite all the signs in the fraction. So if I multiply this, I'm going to have to distribute the negative 1 here and here. What that does is this rewrites my fraction as negative 2x plus 3, because both these signs change, and then both of these signs change. It becomes over positive x minus 3. And then, ta-da, I have the same denominator. So then I can just take 4x plus 5 over x minus 3. And then I can add these. And then, it becomes simple. I just write all of this over the denominator of x minus 3. And then I'm going to combine like terms. So 4x plus negative 2x is just going to give me 2x. And then 5 plus 3 is going to give me plus 8. And that's my answer right there. 2x plus 8 over x minus 3. Now, last thing, we're going to go over 30, 60, 90 triangles. This isn't going to take too long. This is the 30, 60, 90 triangle. You have to memorize it. And I'm absolutely saying you have to memorize it. This will actually be one of our weekly quizzes. I'll ask you to construct the 30, 60, 90 triangle from memory. And just to prove to you that I can do it, I'll go ahead and pull the camera off it here. Now, in your 30, 60, 90 triangle, it's always going to be a right triangle, hence the 90. It will have a short leg and a long leg. The angle adjacent to the short leg, or the obviously bigger angle, will always be the 60-degree angle. The smaller angle will be the 30-degree angle. The opposite side of the 30-degree angle is going to be the shortest side of 1. And the side opposite, the 60-degree angle, is going to be square root of 3. And the hypotenuse will be 2. Now the way I memorized this was to go 1, 2, root 3. 1 being short leg, 2 being the hypotenuse, root 3 being the long leg. And eventually it'll just start becoming easier and easier and easier as you construct it more and more. If you don't memorize this now, you're going to have a tougher time in trigonometry. As this triangle is one of the 2 triangles used for the unit circle, and you can talk to the older grades and how much work that is if you don't have these memorized. Now, the way we're going to use these is we're going to use these in similar triangles for right now, and then eventually we'll start using them in trig identities. If not this year, you will absolutely do that in trigonometry. Now, our similar triangle that we get is going to be another 30, 60, 90 triangle. This one's obviously going to be bigger. And the pieces that they tell us is they give us the 60-degree angle, and they tell us the hypotenuse is 5. The long leg is x, and the short leg is y, and we have to find the parts of it. So they're just going to give you this triangle, and they'll tell you to use similar triangles to find x and y. The similar triangle you're supposed to use is the 30, 60, 90, because you've memorized it. Now, once we have this drawn out on our work paper, it's very easy to do the ratios here. We can just do a ratio of 5 to 2 is equal to x over square root of 3. Cross multiply to solve. We get 2x is equal to 5 root 3, which means that x is equal to 5 root 3 over 2. So that's x. Now y, I can do the same thing. 5 is to 2, as y is to 1. Cross multiply to solve. I got 2y is equal to 5. And then that tells me that y, whoops, it's supposed to be 2. So y is equal to 5 over 2. And that's it for 30, 60, 90s. If you have any questions, let me know on Moodle, and I'll see you in class.